10.
Geometry, Similarity, Day 1, Example 7. Two complementary angles are in the ratio of 2 to 7. Find the measure of each angle.
Angle.
Well, 2x plus 7x is 90 degrees. So 9x is 90 degrees. X equals 10. 2x equals 20 degrees.
70.
7x equals 70 degrees. I don't see that that has anything to do with proportions. That's just regular algebra. So I'm a little baffled about why this problem is here, but at least we have perfectly good answers. 20 degrees, 70 degrees, smaller, larger. Okay, let's move on to example 8. A rectangular classroom is 16 meters long and 12 meters wide. We want to make a scale drawing. 1 centimeter is 4 meters. Okay. The original is 16 meters long and 12 meters wide. Okay. What proportions would we use to find the new scale dimensions? Well, if 1 centimeter is 4 meters, then how many centimeters to 16 meters? Now this is a little tricky because we have centimeters and meters. But the scale factor is the same, so 4 times 4 is 16. So 1 times 4 is going to be 4. Whenever dimensions are given in two different measures, you must convert them to the same measurement. Yes. Now, especially, it's not such a big deal in meters and centimeters, but it's a very big deal in feet and inches. I mean, here we can say 1 centimeter is to 4 meters. Because they're both base 10, but they're 12 inches to a foot. So we want to be especially careful when we have feet and inches. Okay? Okay, so finally we go on to similar figures and the definition. Figures that are similar, and we write similar with the squiggle, have the same angle measures, but not necessarily the same side lengths. when we had congruent triangles, for example, we had same angles and same sides. Two polygons are similar if and only if their corresponding angles, make sure they're corresponding, their corresponding angles are congruent and their corresponding side lengths are proportional. So here we have a right angle. This angle is congruent to this angle is congruent to this angle is congruent to this angle. So we meet the first half of the test. Now, are all the side lengths proportional? 10 divided by 2 is 5, 12 divided by 2 is 6, 8 divided by 2 is 4, 10.8 divided by 2 is 5.4. So my scale factor from here to here is 1 to 2. My scale factor from here to here is 2 to 1. Okay? AB is to EF, 6 is to 12, as 5.4 is to 10.8 is 1 is to 2. Okay? Alright. Determine whether the polygons are similar. If they're both rectangles, we've checked all the angles. Now, if they're rectangles, AD is also 9 and CD is also 6. GH is also 4 and EH is also 6. So now what would be the similarity statement? BA is to FE as BC is to FG as CD is to GH as AD is to EH. We only really need to consider two of these because we have a rectangle, so they're the same. So BA is 6 is to 4 as 9 is to 6. Is that true? Is this a true statement? How can we check? We could reduce both fractions using the calculator, or we could just cross multiply, which in this case is easier. 36 is equal to 36, so the scale factor is 3 to 2. One more example. We have two triangles. We have two isosceles triangles. If this is 62, then this is 62. So the measure of this angle would be what? Would it be 36? Let's see. 62 plus 62 is 124. 180 degrees minus 124. Okay, so the angles are not congruent, so these two triangles cannot be similar. Unless I've made a mistake in my arithmetic, which I don't think I did this time. 36 and 56 are not congruent, plus we don't have the measure of the third side. If the angles were congruent, that would be a different story. When we do write a similarity statement, we want to write rectangle ABCD is similar, squiggle, is similar to rectangle EFGH. Those are the notes. Now we can start on the homework, and we're done.